So the first problem that we're looking at is this entrance ticket. Now the entrance ticket says a number of children are standing in a circle. They are evenly spaced and the 7th child is directly opposite the 18th child. How many children are there all together? A lot of y'all went on and figured out that 18 minus 7 is 11 and went from there. Some of y'all multiplied by 2. Some of y'all subtracted it from 18 and then figured out the difference. And there's many different ways to go about this. One of the ways that we can do this is actually drawing it out. Because in this here, well, the 7th child and 18th child are on opposite sides. Yes? Well, actually, let's go from 7 to 18. Well, I would have 8, child number 9, child number 10, 11, 12, 13, 14, 15, 16, 17, and then 18. Well, that gives us different color. Gold. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 total children actually between them, which means I would need 2, 3, 4, 5, 6, 7, 8, 9, 10 also on the other side. All 7, 6, 5, 4, 3, 2, 1. 18, 19, 20, 21, 22, so there are 22 total. Now, there are different ways to get there, because we could have done 11 times 2, because both sides having the exact same would have gotten us to the exact same place. So there are many different ways to get there. And one that is also very nice is sometimes drawing it out and seeing it as a picture form, because sometimes the numbers work a little better if we can see it. But that's all we had to do for this entrance ticket here. There are 22 kids standing in the circle. Calculating circumference and area of circles, and work backwards to find the dimensions of the circle. So one of the biggest things that we'll be talking about is dealing with circles: radius, diameter, circumference, and area. Now the first term that we're going to look at is ratio, and it's the relationship between two different values or amounts. And we've talked about ratios before. We talked about them when we talked about perimeters and areas. And we talked about, and we did this, one example here. Now the radius of a circle is a line segment from the circle's center to its perimeter around the circle. Now what would we say the diameter is? Yes, but there's a little more information than that. It has to go through the center of the circle. So the diameter is any line segment that goes from one end of the circle to the other and cuts through the center. If we're just going from 2 points on a circle, it's not the diameter, it's actually called a chord. A chord is any line segment that connects 2 points on a circle, which actually would include a diameter. Now, how would you find the diameter if you were given the radius? Because the radius, the diameter is equal to twice the radius, and the radius is equal to half the diameter. Yeah. Well, the circumference is all the way around the circle. Is the measurement of the distance around a circle. Is there a difference between the perimeter of a circle and the circumference? Because what is perimeter? And what's circumference? So is there a difference between these two here? No? Guys, let's get off the Chromebooks. Now, there isn't a real big difference between circumference and perimeter. They're essentially the exact same thing, especially for circles. Now, inscribe, if we inscribe something, we're putting it inside the figure. In this here, they will talk about a good bit, especially it will come up on tests. They won't necessarily draw it, but they will talk about a circle being inscribed in a square, rectangle, or figure. And really what that means, picture-wise, is that if we had a square, the circle is inside of it. It's inscribed. To draw a figure within another so that their boundaries touch but do not intersect or cross. Because for it to intersect, it means it has to cut it. So here, they do touch, but they don't actually cross. They don't go outside of each other. And they'll do that for finding, say, the circumference of a circle if it's inscribed in a rectangle. That means the dimensions are going to be contained within that one there. Then it would be inscribed inside the circle. And circumscribe is to draw a figure outside of another so that their boundaries touch but do not intersect. So inscribed is in the center, circumscribe is on the outside. Circumference and perimeter is 2 pi r. The circumference of a circle is 2 pi r. Now, we can actually write it another way. So pi r, that is still dealing with the circle, but that would be not perimeter, but area. Area is pi r squared. We can actually say that the circumference is, well, 2 times the radius is what we call the diameter. So we could actually say that the circumference is the diameter times pi. So diameter can also be used to find the circumference. And a lot of times we get in the habit of taking from diameter back to radius and then finding the circumference. But if I'm already given the diameter, we can just stick pi on to it and we're done. If I'm given the radius, double it and attach pi. And a lot of times if they do ask us to compare the circumferences and they give us the radius, we're really just comparing the radiuses because the pi r, 2 pi r are going to be the same. Yes? Times 2 is going to be 6. Yes. So we have these two different forms here. Now, one of the things, especially to be cautious when we talk about circles or volumes of spheres, anytime pi comes into play, is you need to be paying attention for what they want. In some questions, if they don't specify with pi, it might leave it in terms of pi. They might want you to leave your answer with pi. In others, it's going to probably want you to use the pi key on the calculator, 3.1415926, the irrational number. And there's others that are going to use 3.14 as pi. So in each of those different cases, we need to know which version we're using. Because in most, 3.14 and the 3.1415, the elongated version, isn't going to make too big of a difference. But once we start getting bigger numbers, that extended version of the decimal will change the value. Not by more than like 1 or 2, or amounts to where it's going to make a different value. So we have to be paying attention for that. Now, this is part of the note sheet, the first part here. I definitely need the book because I did not memorize this. In a galaxy far, far away, the Circonian Martians have made a monumental discovery. A planet not unlike their own, inhabited by a strange race of creatures. There are no corners in Circonian world, and no straight edges either. Their bodies are round, their food is round, and they live in a circular dwelling. However, this new planet is full of other shapes. This new planet is full of other shapes. The harsh edges and bold corners of this universe unknown planet worry the Circonians, who are headed to the planet to deliver a message to its strange, lanky inhabitants. The Circonian Martians boarded their spaceship, ready for voyage to this newfound land. They enter the Milky Way galaxy near Pluto and stop there to greet their distant aliens. The Iskans aliens, who live on the cold, rocky planet. Eventually, the Circonians reach Saturn, a planet they are rather unfamiliar with. They mistake the rings of Saturn for roads the inhabitants of Saturn have constructed. The captain of the spaceship believes the road is a shortcut to their destination and steers the ship along its direction. Before long, the spaceship's crew start to complain. It seems like the road is never ending. Yep. So they're trying to travel. So the Circonian Martians are traveling the outermost rings of Saturn 3 times before realizing they are going in circles. How far out of their way have they traveled before they get back on the route towards their destination? So how far would they have gone? So that'd be the circumference, which is 2 pi r. And they said they've gone 3 times circumference, which would be, well, 3 times 2 pi r, yes? And if we plug that in, we would get what? Okay, that would actually be good to know, wouldn't it? Now, the radius of Saturn actually works out to be 36,184 miles. Okay, that's quite a good distance if you're going from the center of Saturn to the surface. Well, to the outer ring, so from Saturn's surface to the outer rings where they're at, it is a total distance of 8 million miles to the outermost ring. And most likely we're talking about the visual spectrum. So the visual actual rings. Because there's actually another set of rings that are only visible in the ultraviolet that are actually even farther away. And if you pull up pictures, and I can pull up pictures in a minute, Saturn looks about yay compared to the other set of rings. So, what would the actual radius for this here be?
Would it be 8,036,086?
Yes. Because when we talk about circumference, we want the radius from the center of the circle. Well, the center of the circle is not from this Saturn's surface, it's actually from the center of Saturn, which would give us this here. So, the circumference for them that we're going to need is, well, 3 times, because they went around 3 times, 2 times pi times our radius of 8,036,184. With the pi, and if we calculate pi in, we get 151,401,706.6, or approximately 151 million miles. And as they say here, good thing their spaceship travels fast. If we talk about space travel, especially approaching the speed of light, it actually gets kind of fuzzy with time actual passing, because the time that passes on the ship is actually different than time passing outside the ship relative to the spectrum, because people on the ship actually experience time slower than the people outside. And if we actually reach the speed of light, it's almost, I think they said, if I'm remembering correctly, for each year inside the ship, it's almost, I think it's like almost 1.8 or something like that years experience outside. It's pretty much for us. And it's even, actually, I think it's even more than that, because I think they said by the time it takes for us to get from here to the edge of the universe and back, or just the edge of the universe at the speed of light, it would take about 60 to 80, I think it's like 80 years. But the time that would have passed on Earth would have been in the thousands. So most likely, if we were able to achieve that and go to the edge of the universe and back, there might not be anything left on Earth, because it would take so long. Not for them, but for time on Earth. So we're going to look at a few more examples with circumference and area. So these here are on your notes, circles A, B, and C. It's just 3 questions right there. So the first one, what is the circumference of this here? So again, circumference is equal to 2 pi r, which exactly would be 2 times 5 times pi. Well, 2 times 5 is 10 pi. Now, if we treated pi as the irrational number, so if we did 10 pi and converted it into the calculator, we would get what? Just keep going. 31.4. Okay. Now, if we did, instead, we treated it as 3.14, it would be 31.4. So there's not a huge difference here. So here, no matter which one we choose, we would have actually gotten close. Any questions on this here? All right, let's look at the next one. What is the circumference of circle B? Here, I would use diameter times pi. Because if we wanted to use 2 pi r, well, we would have to divide the diameter by 2 and then multiply it by 2 pi. If we use diameter times pi, well, that would be 20 times pi. And if we use 3.14, this would give us E2 point. And if we just use 3.14, it would just be 62.8. So really, for the first 20 numbers, it's not going to be too big of a difference between pi and 3.14. Any questions on this here? All right. Let's look at the last one. Here. What is the radius? Circumference is equal to 2 pi r, yes? And we want to find the radius. Well, we know the circumference is 30 pi, which is equal to 2 pi r. Well, if I want to get the radius by itself, we can divide both sides by 2 pi. Because here the 2 pi and 2 pi will cancel, leaving us with just r. Well, here pi over pi cancels, leaving us 30 divided by 2, which is 15. Now we also said that the circumference is equal to diameter times pi. So that's also telling us that the diameter for this circle is, and the radius is always half of the diameter, so we just have to divide 30 by 2 to get to the value of r for the circle, which would tell us that the radius is 15. All right.
So usually the circumference
Almost pi. Because circumference is diameter times pi. And if they don't put pi in, if they don't multiply together, then we don't, it's just the number. But if they don't include pi, 30 pi, then we need to divide it by pi to get the diameter. All right, we'll stop.